So here are the results that we got from our lab. We're going to go ahead and try to calculate what is the specific heat of our unknown material. So the mass of this weight was 199.93 grams. So that's going to be equal to 0.19993 kilograms because we need to get that into kilograms. And if you remember the mass of distilled water, we had 100 milliliters, which equals 100 grams, but in kilograms, that's going to be 0.1 kilograms. So we have, that's the mass of our mass, and this is the mass of the water. The initial temperature of the weight when I pulled it out was 78.48 degrees Celsius. The initial temperature of the water before putting the weight in was 19.7. That was according to what I saw on the screen, 0.7 degrees Celsius. And the final temperature of the weight and the water, that was 30.57 degrees Celsius. So we're going to plug this into this formula up here. Remember that delta T is going to be T2 minus T1. So this is the heat that is being lost. This is the A is going to be my weight. And the heat is going to be gained by the water. So the water is going to be our B. So when doing these calculations, let's go ahead and we'll set up the formula. This is very much just like what we did in the lecture. The heat is being lost by the weight. It's being transferred to the water. So the negative QA is going to be equal the QB. That which the heat is lost from the weight is going to be gained by the positive Q over here by the water. So let's plug in our formula of the MC delta T. So we have a negative, the mass of A times the specific heat of A, which we're trying to calculate, times the temperature change for A. Again, temperature change is going to be T2 minus T1, is equal to the mass of B times the specific heat of B times the temperature change of B. Okay, so let's rearrange because we're trying to solve for this. So we're going to divide both sides by the negative mass of A and the temperature change times the temperature change of A. So we'll divide this side also by the negative mass of A times the temperature change of A. So the specific heat of my weight is going to be equal to this right here. It's going to be equal to, in the mass of B times the specific heat of B, and this is going to be the temperature change of B. This is going to be the TB2, which is just our T2. So it's going to be the T2 minus the T of B1 is all going to be divided by the negative mass of A times the temperature change of A, and that's going to be T2 minus TA1. So I'm going to kind of pause here and let you guys see if you can figure it out, and I'm going to plug in the numbers and then plug in my calculator, then I'm going to do the answer and we'll discuss what it is after that. So press pause now, see if you can solve for this, and we'll be back in a minute. Hopefully you paused and you plugged in all of our numbers. So the mass of B, this is going to be our water. So we have 0.1 kilograms. The specific heat for my water, this is coming from lecture, we have 4,180 joules and over kilograms degrees Celsius. Then we have the T2 minus the TB1. The T2 is my 30.57 minus my TB1, which is my 19.7, divided by the negative mass of my A. Negative mass of my A is going to be 0.19993 kilograms. This is degrees Celsius over there, by the way. Minus the multiplied by T2. T2 is going to be the same temperature, 30.57, minus the TA1, and the TA1 is 78.48 degrees Celsius. So plug that into your calculator and see what you guys get. You can pause and come back. After plugging that into my calculator, I get 474. And the specific heat can be measured in joules over kilograms degrees Celsius. So what does that mean? Let me give you a couple of things, a couple of specific heats. Brass, which we could have used a brass weight, and brass, the specific heat for brass is going to be 376 joules per kilogram. So it's not brass. It was shiny and silvery. And another one is iron. Iron is going to be 450. However, this is not just any particular type of iron. This is actually steel, which has some chromium mixed in with it as well. And if you look at the specific heat of steel, you'll see that it is going to be 460. So this is highly likely that it is going to be steel because of its specific heat.